In this question, we are given a matrix A, which is of the order 3 by 3, and the elements Aij is given as the modulus of I minus j divided by 2. So using this information, we have to find out the value of the element A23. So in order to find out the value of A23, we set I is equals to 2 and j is equals to 3. And then we plug this value into Aij. So A23 will give us, in place of I, we'll replace it by 2, and in place of j, substitute it by 3, the whole thing divided by 2. So this gives us the modulus of -1/2. Now, the modulus of a negative value is always positive, so it's simply going to be 1/2. So A23, the element A23 in the 3 by 3 matrix has the value 1/2. Let's go to the next question. So here we have three matrices multiplied to each other such that the resultant is, this is a zero matrix. It's not simply 0. So using this information, we have to find out the value of x. So we begin by multiplying the first two matrices. So let's write down the entire matrix. This is 2x3. This is a row matrix multiplied to 2 by 2 matrix of first row 1, 2, and second row -3, 0. And it's multiplied to a column matrix x3 equals to the 0 matrix. Now when we multiply the first two, so the first matrix is of order 1 cross 2 and the second matrix is of order 2 cross 2. So when we multiply them together, so we should get a matrix of the order 1 cross 2. So that means we'll have only one row with two columns. So let's get to it. So we'll multiply 2x to 1 and add it to 3 times -3. So this will be the first element. The second element will be 2x times 2 plus 3 times 0. And the remaining column matrix x3 is equals to 0 matrix. Let's go down. So this will give us 2x minus of 9. This will be the first element, and the second element will be simply 4x plus 3 times 0 is 0. So that gives us a row matrix, and we have a column matrix. Now, a row matrix is of order 1 cross 2, and the column matrix is of order 2 cross 1. So when we multiply them together, then what we get is a matrix of the order 1 cross 1. So this will be 2x minus 9 times x plus 4x times 3, which is equals to the 0 matrix. Now let's simplify. This will give us 2x squared minus of 9x plus 4 times 3 is 12. So this is 12x equals to 0, or the 0 matrix. So 2x squared plus thrice x equals to 0. So this is a single 1 by 1 matrix. So the 0 matrix can also be written as a 1 by 1 matrix having an element 0. Now since this matrix are equal, so we equate them. So equate twice x squared plus 3x equals to 0. We factor out x, leaving us with twice x plus 3. So this gives us the value. This gives us the value x equals to 0, or we have twice x plus 3 equals to 0. When we solve for x, we should get -3/2. So these are the two values of x, which is 0 and -3/2, when we solve the given matrix equation. Let's move on to the next question. So in this question, we're given a matrix equation. So using this information, we need to find out the value of x minus y. So to do that, first let us rewrite the matrix equation. So this is 2 times the 2 by 2 matrix, 3, 4, 5x, plus second 2 by 2 matrix, which is 1, y, 0, 1, equals to another 2 by 2 matrix, which has the values 7, 0, 10, and 5. Now, starting with the first matrix, we are going to multiply the scalar value 2 to each of the entries. The first matrix, so that should give us 2 times 3 is 6, 8, 10, and 2x, plus our remaining matrices. 1 equals to 7, 0, 10, 5. Now the first two matrices are of the same order, so we're going to add the corresponding elements. So the first element will be 6 plus 1, so this give us 7. Then we add the second element of each of the matrices, so that will be 8 plus y. The third element will be 10 plus 0, which is simply 10. And the fourth element is twice x plus 1. That's equals to 7, 0, 10, 5. Now, that these two matrices are equal, they are of the same order, so that means we can write 8 plus y equals to 0. On solving this, we get y is equals to negative 8. For the fourth entry, which is twice x plus 1, that will be equals to 5. So solving for x, we'll get 2x is equals to 5 minus 1, which is 4. Then we divide both sides by 2, that should give us x equals to 4 divided by 2 is 2, so x equals to 2. Now that we have the value of x and y, so we can find out the value of x minus of y, which is equals to 2 minus of 8, which is simply 2 plus 8, so that gives us 10. So that's the value of x minus y. Okay, let's move on to the fourth question. Here we are given an equation, a matrix equation. We have to find the value of x. So we have a row matrix which is multiplied to a 2 by 2 matrix. The entries 1, 0, negative 2, and 0. And this is equivalent to the 0 matrix. So we multiply them, we'll get x is multiplied. The first row will get multiplied to the first column, so that should give us x times 1 plus 1 times negative 1. Then we multiply the first row to the second column, so that should give us x times 0 plus 1 times 0, which is equals to the 0 matrix. We further simplify it, so that should give us x minus of 2. So this entire expression will give us 0, which is equals to, now let us expand this 0 matrix. Now we have a row matrix which is of the order 1 cross 2 on the left hand side. So our 0 matrix will have also be a 1 cross 2, which will also, that means it will also be a row matrix with 2 entries, like 1 row and 2 columns with the values 0 and 0. Now we equate both the sides, so that should give us x minus 2 equals to 0, which implies x is equals to 2. So that is the value of x. Moving on to the next question. If A is a square matrix such that A sub squared is equals to A, then write the value of 7a minus I plus a cubed, such where I is an identity matrix. So let's start with our expression. We're given 7 of A minus I plus a whole cube. So what we're going to do, we're going to expand I minus I plus of a whole cube using the identity a plus b whole cube. So we'll get I cubed plus 3 I squared a plus 3 I times a squared plus a cubed. Okay, now we know that I cubed, which is an identity matrix multiplied to itself 3 times. Not 3 times, I is multiplied to I, that gives us I squared, which is again multiplied to I. Now when our identity matrix is multiplied to itself, that gives us the identity matrix itself. So I cubed can be rewritten as I. Similarly, for I squared, we can say this is simply I times I, the product of two identity matrix, that gives us I. And a squared, we'll be replacing it with a cubed. So a cubed is a multiplied to a squared. Now a squared is given in the question, it's simply a. So a squared, we can replace it by a. Now a times a is again a squared, which can be written as simply a. So we can say that a cubed is simply a. So let's plug these values into our expression. So that gives us 7 of a minus of I plus 3 i's of a plus 3 i's of a plus a. Also, we know that an identity matrix multiplied to a matrix gives the matrix itself. That is, I times a will give us a. So we can write 7a minus I plus a whole cube is simply equals to 7a minus I plus 3a plus 3a plus a. Then we combine all the like terms within the parentheses, so that should give us I plus 7a. Then we open up the brackets, that should give us 7a minus I minus 7 of a. So 7 of a and negative 7 of a are additive inverses of each other, so that leaves us with only negative I. So this is the simplified form of 7a minus of I plus a whole cubed. That's it.